Question 6 is just going back over question 1, 2 and 3. It's like 2 questions in one. So if you haven't done it, I'm just going to go through G just to show you. And if you have done it, I want you to check. Have you been as accurate as you possibly can? Okay, so if we look at this question, it's asking us to find this unknown length here, x. And so if we look at this triangle that x is associated with, all we've got is a length of 4. We haven't got enough information. So what do you think that we have to do? Anyone? Anyone? Yes? Micah? Right, we have to use the other triangle to actually find this length here. So what should we call that length? You could call it C, you could call it Y, you could call it anything except for X. Yeah, well done, guys. Some of my classes before would say, oh, X, no. So I'm going to call this Y. And so what I'm focusing on, and you don't have to draw the triangle again, I'm just showing you there. So this is what my eyes are looking at. And this now becomes a really simple Pythag problem. Would you agree? We've got the 2 lengths that make up the right angle. So this is 2 squared plus 5 squared equals y squared. This is where we might differ just a little bit, because I'm going to do this. I'm going to say, well, 2 squared is 4, 5 squared is 25, and so therefore, tell me if I've gone too fast here, but no, that's okay. So why is it root 29? Because 2 squared is 4. I've done this on my calculator. 5 squared is 25. So I've got that equals y squared, and therefore y is root 29. I am not going to go to the decimal. I'm going to leave it as root 29. Does anybody know why? Yeah?
Maybe so it's accurate.
Exactly. I want to try and be as accurate as possible. Because I'm now using this figure to get my next answer, I don't want to do any rounding off until the very last moment. Okay, so now I'm looking at that last triangle, which is the 4. It's got the x, and now my y, I know, is root 29. So what are my 2 lengths that make up my right angle? Miles, have you done this question? Okay, so then we shouldn't be smirking at Jordan. We should be actually doing the question and getting it down, okay? So what are my 2 lengths that make up my right angle in this case? Pardon? X and 4, fantastic. So that will now be x squared plus 4 squared equals, what is my hypotenuse? Root 29 squared. Who can remember from last? Why should I go, oh, silly me? Did I have to write root 29 squared? That's right. The root and the squared are opposites and they cancel each other out. So, silly me, I could have written that as my first line, but if I didn't, it's no problem. Okay? That's what we love about maths. You can just sort of keep on trucking, keep on trucking. Now, how do I get rid of? I want to get x squared by itself. Carolyn, are you okay? Are you paying attention? Because if you then go, I don't know how to do question 6G, and I've seen that you're not paying attention, it's not going to go down well, is it? So, how do I get rid of the plus 4 squared?
You take it to the other side and minus it.
Excellent. So, I'm going to now say this is 29 minus 4 squared. That will equal x squared. You can see I'm running out of room, Amy. How do I get rid of the squared?
Root.
Square root. That's right. Square root. We remember that? Yep. So into the calculator, I haven't left myself enough room. So can you please, I don't know what message that was that I just minimized. can you please fill that in? So, for those of you who have not done question 6, I'm asking you to do 1, 2, 3 questions and then pick one more. But you will have to do that in about 5 minutes. When I say 5, I mean 10, because I still want to keep talking, Carolyn. So that's a reason why we want to make sure that we are doing our homework. So you're not then going and playing catch up and falling behind. And if I didn't tell you to do that for homework, my bad, I apologise. I think you were running out the rooms and I forgot to make you put it in your diary, if I recall. Okay, the reason I'm going to make you stick with me is because the next bit that you have to do, repeat, repeat, repeat. Are you frowning at me? Trust me. I know there's not a lot of time that you can trust, but trust me. So, converse of Pythag. You're using it in the opposite way. So instead of us saying, here's a right angled triangle, use Pythagoras' theorem, we're going to ask you, is this a right angled triangle? So, why? So yeah, there's no little square, but remember we said right from the beginning, why is it important that we use Pythag? It's used in a lot of building places. I use it in my house as well when I was paving, when I put up a pergola to make sure that my posts were straight. I actually use Pythag to measure. But anyway, so we are going to see if the triangle fits Pythagoras, then it is right angle. If it doesn't fit, it's not right angle. Frowner at me again. Frowning. I'll call you Frowner. So, if I want to plug this first one, right, into Pythagoras' theorem, we can't just go with, it looks like a right angle. How do we know that if it was, if 10 would be the hypotenuse? Why would we say that? Yes, Amy? Yes, except there's no little square. Yes. Why else, Aidan?
Because
That's one reason.
It's the one that's going across. It's not the two that are connected to
Yes, it's going across. It's the highest number, right? We know that the hypotenuse is the longest side. So if this is a right angled triangle, would you agree that 3 squared plus 6 squared should equal 10 squared? Do we agree? So it should, if it fits if it's right angle. If right angle triangle. So this is what we're now going to do. I'm going to go 3 squared plus 6 squared. That is 9 plus 36, 45. And that does not equal 10 squared, does it? So therefore, not. Look at this now. Look at that. Not right angle. I'm sick and tired of writing a right angle. So I'm writing that little thing. I'll do it again because it looks a bit messy. It is not. Oh, technology, you vex me. It's frozen on me. I don't know. It's back. Okay, so I would write not a right angle, triangle. So maths has got its own language and shorthand. Hello, Miles. Once we're done and we're happy, this is the final bit for Pythag. Remember, this is only a 2-week unit. This is from your book on page 158, but you're going to now do worded problems. It's only the same problems over and over again, either finding the hypotenuse or finding a non-hypotenuse side. You've just got to figure out where the right angle is first. So this is really important, and I would like you to make sure that you have drawn these diagrams in your book. You don't have to do all the writing, but you have to see where the do you have to do the rectangle? No. We all know that there's a thingy there, don't we? We all know there's a right angle and a rectangle?
Yeah.
So then you don't have to copy that one down. Did we know that the diagonals of a square intersect at right angles? So if you didn't know that, write it down. If you did, that's okay. Rhombus. Diagonals of a rhombus intersect at right angles.
It's just a square, they're lopsided.
And this means this length is the same as this one. This one is the same. There's actually, would you believe, this, but they didn't want to put too many lines all over the place. So we should know that a rhombus is just a
Lopsided square.
lopsided square. I say pushed over square, and I think when I went through school they said it's a drunken square, but I don't think we're allowed to say that anymore.
It's like if you get a cardboard box and you knock it over side.
Correct. But anyway, the important thing for us to know is where is the right angle? It's with the diagonals. And same, isosceles triangle, you cut it in half, there's your right angle. Equilateral triangle. So those things we need to know. And if you check day map, what I'm then asking you to do, so by the way, right, check, please check day map. I'll rock it up in a minute. You're not doing any of this stuff. You're scooching along to the problem solving, and you're going to try and have a look at those, okay? And I'll be able to come around and chin wag with you. All right, good luck.